No lesion left behind. How to optimize endoscopic surveillance for Barrett's esophagus. These are my co-authors. These are my disclosures. Barrett's esophagus is a pre-malignant condition due to columnar metaplasia of the normal squamous esophagus. Endoscopic surveillance aims to detect dysplasia or cancer at an early stage to enable timely intervention. Endoscopic surveillance should be performed at regular intervals based on the length of the segment, approximately every 2 to 5 years. Detection of dysplastic Barrett's esophagus relies on high-definition white light endoscopy, optical enhancement, and systematic sampling. So routine Barrett's esophagus surveillance is performed in line with current British Society of Gastroenterology guidelines. A gastroscopy is performed under sedation with a gastroscope that allows enhanced imaging. We demonstrate a systematic assessment of Barrett's esophagus to optimize the detection of neoplasia. We present a 58-year-old male undergoing upper gastrointestinal endoscopy for Barrett's surveillance. They were diagnosed with long segment Barrett's esophagus 5 years ago and have been under surveillance. They are currently asymptomatic, smoke 5 to 10 cigarettes per day, and use omeprazole 20 milligrams orally twice daily. These are our endoscopic equipment. So after a complete upper GI endoscopy, the area of Barrett's esophagus is assessed in more detail. Initially, the mucosa is cleaned with water and simethicone to enable adequate visualization. After washing, it is important to assess for and measure any hiatus hernia. This is particularly important to help identify the Z line. First, find the diaphragmatic pinch, here marked blue. Next, find the top of the gastric folds. This is where the Z line will typically be located. The distance between the two marks is the area and size of the hiatus hernia. So here showing the top of the gastric folds. So the Z line cannot be found here because of the presence of Barrett's esophagus. The endoscope should then be withdrawn slowly to observe the columnar-lined esophagus and identify the maximal extent. A columnar-lined esophagus typically appears as a salmon pink color with a velvety texture and sharp transition with a surrounding squamous mucosa. So once you've established the maximal extent of the columnar-lined esophagus, shown here, and you know the location of the top of the gastric folds, you can measure the Barrett's using the Prague classification. This is divided into the circumferential extent, shown here, and the maximal extent, shown here. The circumferential extent is the length in centimeters of continuous circumferential columnar-lined esophagus, and the maximal extent is the furthest point where Barrett's mucosa extends. After measuring the Barrett's, a thorough assessment should take place in both white light endoscopy and optical enhancement, here being shown in iScan 3 by Pentax Medical. iScan 3, like other optical enhancement tools, digitally modifies light absorption characteristics, which enhances vascular structures and pit patterns. Remember that dysplasia is most commonly observed between the 12 o'clock and 6 o'clock position when using a clock face looking down the endoscope. So it's important that assessment is dynamic, moving the endoscope up and down the segment carefully, checking for any asymmetry, macroscopic lesions, esophageal motility, and surface bleeding or friability. As a benchmark, assessment should be for at least 1 minute for every 1 centimeter of Barrett's esophagus. A longer inspection time is associated with higher detection of dysplasia. So here, we can see evidence of a lesion at the bottom of the Barrett's. However, on careful review, the posterior segment is slightly elevated, irregular, and asymmetrical. This area is also concerning for dysplasia. A distal transparent attachment has now been placed to enable better mucosal visualization. First, the initial lesion is assessed in white light endoscopy and optical enhancement, ensuring regular washing to clean the mucosa and allow good visualization. So here, the pits appear irregular, elongated, and form complex raised patterns that are suggestive of dysplasia. Compare this to the neat, regular pits of non-dysplastic Barrett shown in the image on the left. Next, the posterior wall is assessed, which again shows irregular, complex pits and raised mucosa consistent with neoplasia. It is important to carefully assess the perilesional tissue for the circumferential extent of dysplasia. Here, on optical zoom and image enhancement, we can see the irregular, tortuous, and dilated vessels, which are almost corkscrew-like in appearance and suggested of dysplasia. Once the assessment has been completed, the segment of Barrett should be biopsied using the Seattle protocol. This is a standardized strategy for sampling Barrett's esophagus. It involves 4-quadrant random biopsies for every 2 centimeters of Barrett's esophagus, in addition to targeted biopsies on the macroscopically visible lesions. The nomenclature anterior, posterior, right, and left should be used, with M referring to biopsies of all 4 regions. So this patient had evidence of early intramucosal adenocarcinoma and widespread high-grade dysplasia on biopsies. They were discussed in the multidisciplinary team meeting and underwent piecemeal endoscopic mucosal resection. Histology showed no evidence of high-risk features, and they subsequently proceeded to endoscopic eradication therapy with radiofrequency ablation. So in conclusion, thorough mucosal preparation and cleaning is absolutely essential to allow visualization. It is important to combine high definition white light with optical enhancement to aid dysplasia detection. Ensure you systematically assess each area and segment to prevent missing synchronous lesions, and use a systematic approach with a Seattle protocol to obtain tissue samples.